Okay, this is Math 116, Section 2.1, and it's all about solving quadratic equations. So to solve quadratics, we have a couple of different methods we can use. First one's going to be factoring. So just a reminder of some of the factor we learned back in 0.5. This one is the kind with the squares on the end, so it comes out to the something squared. It's the a squared, 2ab, b squared. So this is going to be 5x and then minus 1 quantity squared. So that's a minus b quantity squared. And then to solve this, I just do 5x minus 1. Remember, this equals 0. So 5x minus 1 equals 0. I bring the 1 over and then divide over. And so I get 1/5. So if I put 1/5 back in here, the 5's would cancel. 1 minus 1 would be 0. That would equal 0. So 1/5 is a number that if I put it in this original equation, it's the x that makes it come out to 0. For number 2, we always want these to be in the form ax squared plus bx plus c equals 0. And so I'm going to move the 35 over, so I get that equals 0. And setting up parentheses, so this one's 3 terms, leaves with a 1, so x is in front, and it'll be a plus 7 and a minus 5 to make it multiply to negative 35 and add 2. The factors and zeros always have the opposite sign, because when I set this equal to 0, then I do the opposite to bring it over, so we get x equals negative 7. So since this is x minus 5, it'll be a positive 5 for the 0. Okay, for number 3, I'm going to distribute the x, get x squared plus 2x. And I don't want it equals 80, I want it equals 0, so I'm going to subtract the 80 over and get equals 0. And now I can factor and solve. So x plus 10 and minus 8 should work. So x is going to be negative 10, or x is going to be 8. For number 4, that one's got a denominator, so I would clear the denominator. So I'm going to multiply both sides by x to get that x out of there. So up front, that'll give me x squared. And then here, the x's cancel, leaving just minus 11. And then equals negative 10x. And again, I want this to 0, so I'm going to bring this over. So x squared, and that'll be plus 10x minus 11 equals 0. And then I can factor x plus 11 and x minus 1. It would make the 10 and the 11. So x is either negative 11 or positive 1. Number 5. Okay, so this one's a little funky. If you hate everything that I'm about to do, you can absolutely write these side by side, FOIL it out, distribute the 3, collect it all, and then factor. That will work. I'm going to try to show you a method. It's really easy to do once you figure it out, and it's a little bit hard to figure out. So pretend for a second that instead of an x minus 5 here, pretend like this was a y, just because it's easier to look at. So if I just thought of this as y and y squared, then I can look at that and totally factor it. So multiplies to negative 28, adds to be 3, so plus 7 minus 4. So if I just look at this the right way, I can factor it the exact same way I did this bit. So here the y was kind of standing in for the x minus 5, and the y standing in for the x minus 5, there's the squareds. So I can really, instead of writing this, I could just go x minus 5, x minus 5. Instead of y and y, I'm just using this chunk of math. And it's going to be the exact same plus 7, because it still has to multiply to be negative 28, and add to be 3. So negative 7 and positive 7, negative 4. And then I just collect it from there. And negative 2 and positive 9. So those are the values that if you put in here would make this come out to 0. So again, you could FOIL this out and then distribute the 3 and then collect all of that, and you'd end up at x squared minus 7x minus 18 if you did that. And then you could factor But if you can see this, it's a much easier way to do it in class. So this is going to go 3 plus 5x and 3 minus 5x, because that's our a squared minus b squared, so it comes out a plus b, a minus b. And then setting each of these to 0 and solving, you'll get x equals negative 3/5 on this one, and then positive 3/5 on that one. Number 7 is the too easy, it's hard. First thing I'm going to do is get it set to 0. So x squared minus x equals 0. Factor an x out. And then from there, if you can just spot factoring the x, then it's not too bad. When we have an x out front, remember that's x equals 0, because if this was 0 times -1, it would still be 0. And then this one would be x equals 1. For number 8, I would clear the fractions, because I think that will be much easier. So 6 over 6 would cancel, leaving x squared. 6 over 3 would cancel, leaving minus 2x. And then 6 times 4, negative 24. And separate parentheses, x and x. Looks like minus 6 and plus 4. So x could be 6 or x could be negative 4. This is one where we need to FOIL it out and then get that negative 2 incorporated. So foiling this, we're going to get x squared minus 3x plus 2x, and minus 6 equals negative 2x. Collecting, x squared minus x minus 6 equals negative 2x. And then finally I'll add that 2x over. So x squared plus x minus 6 equals 0. And then if I factor that, x plus 3, x minus 2, and x equals negative 3, or x equals 2. And number 10, so this is the one, again, you can FOIL it all out, or if you can kind of look at it, like I said, as y's, standing in for the x plus 4, then we can just kind of realize it's going to go y plus 9, and then y minus 2 equals 0. So that means if we factor it this way, it would just be x plus 4 plus 9, and x plus 4 minus 2 equals 0. And then putting those together, plus 13, 4 minus 2, so x plus 2 equals 0. So x is either negative 13 or negative 2. Okay, so we could do 11 the way we were just doing them, but this is kind of where it starts to shift to where we could use the square root property also. And the square root property goes, if we have a squared equals b, I can root both sides of that, but there's ambiguity. I don't know if it was positive times positive or negative times negative, because they both would have made a positive number. So I need that plus or minus on the other side. So if I have a squared equals b, then a equals plus or minus root b. So instead of FOILing all this out, what I can do instead is just take the root of both sides, since I have a squared that I want to undo, and roots undo squares. So I root both sides. And then square root of x plus 3 squared, these knock each other out, and I just have the x plus 3 equals plus or minus root 16. So root 16 is really 4, so x plus 3 equals plus or minus 4, bringing the 3 over, x equals negative 3 plus or minus 4. So that's really two totally separate numbers. It's x equals negative 3 plus 4, or it's x equals negative 3 minus 4. So negative 3 plus 4 would be 1, and negative 3 minus 4 would be negative 7. 12 and 13 are the ones I'd have you guys try. So for this first one, we would just root both sides, plus or minus in there. So we end up with square root of x squared, so that's just x equals plus or minus root 11. For this one, same idea. I'll root both sides because I have a square. So that makes x minus 2 equals plus or minus square root 49 would be 7. Add the 2 over. X equals 2 plus or minus 7. So that would be x equals 2 plus 7 would make 9, or 2 minus 7 would make negative 5. Okay, so that gets us to the quadratic formula, which is given ax squared plus bx plus c. If we solve that very, very carefully, it'll take about half a page. For x, we get x equals this. So the quadratic formula is really just this standard form of quadratic solved for x. In this, the a is the coefficient for the x squared term, b is for the x term, c is for the constant on the end, and basically we just grab these three numbers. So in this case, a equals 1 because it's 1x squared, b equals negative 10, and c equals negative 6. And we plunk them in the formula and then clean it up, and that's pretty much what there is to the quadratic. Sometimes simplifying can be a little bit of a bummer, but in general the idea of it's fairly friendly. So we got negative and negative 10 because it's negative b. So you could just write positive. You could just think of it's the opposite of whatever's showing. And then plus or minus negative 10 squared. Careful to get parentheses around that. Minus 4, a is 1, c is negative 6. And then all over 2a. So 2 times 1. So that will be x equals negative 10 is 10 plus or minus 100 minus, plus double negative, so positive, 24 over 2. So that's going to be 10 plus or minus 124 over 2. And then this is the part where it gets a little bit dicey. So you have to check and see if you can reduce this radical at all. So it'd start kind of trying to divide by perfect squares. And if you go 4 divided into 124, you're going to find it's 4 times 31. So if I think of that being under the radical, then I can bring that 4 out front, and that's going to get me, here's the 10 from there, plus or minus. So this will be 2, and then root 31 is left inside. So that's the first step for reducing. And then the second step is if there's something that goes into all three numbers that aren't under the radical, so all the ones that are just plain numbers, then we can reduce it out. So in this case, 2 goes into 10 5 times, and then plus or minus here, the 2 over 2 would just cancel, leaving me 3 and 1. Or you can think of it, 2 goes in 5, 1, and 1, which is another way of saying that. So this is the matched problem I'd have you guys try. So x equals negative b, so that'd be negative 5, plus or minus 5 squared minus 4 times a times c, all over 2a, so 2 times 1, and it makes x equals negative 5 plus or minus 25 minus 28 over 2, and putting those together I get negative 5 plus or minus negative 3 over 2. So this time this came up negative, and you may remember from math 95 or 98, if you have the square root of negative 1, that's an imaginary number. So this is business math, so we're not going to be looking for imaginary roots for things, we're looking for the actual roots. We're going to be interested in what these roots are. We got a little bit of graphing coming up, so I'll just take a second here and explain it. When we have two solutions to a quadratic, what we're really finding is these two x-intercepts. When we have one solution, that's like it comes down and touches and then goes back up. And then we can also have a case where you have no solutions, and that's where we get these imaginary values. So in this class, we're going to be concerned with these two, not the imaginary ones. So for this on the computer, you would just say no real solution. Okay, so number 16 goes, suppose the profit from the sale of X units of a product is given by profit equals that math. What levels of production will yield a profit of that many dollars? And then we're going to 2 decimal places. So the profit is the P, so that would go in on the left-hand side. And then this will equal the right-hand side. And then what I'm going to do is I think I'm going to bring everything this way just because I don't love these negative signs. So I'm going to bring this over here and get it equal to 0. So that's going to give me 18x squared. And then bringing that over will be minus 6400x. And then adding this over will leave, or will make it plus 175,000 and then 400 for 800 equals 0. So A is going to be 18, B is going to be negative 6,400, and C is going to be this gigantic 175,800. And so it's quadratic, so we can put it in the quadratic formula. So that will look like this. So 6,400, it'll be positive because that's opposite, plus or minus negative 6,400 squared. Careful when you're putting that in the calculator to get the parentheses around it, because otherwise it will report a negative value there, and it should be positive because we have two negative signs. Minus 4, A is 18, and then B is that giant number, all over 2 times 18. And so I put all of this in the calculator and got another giant number, and then took the square root of that giant number, and that got me to right here. So the square root of the giant number came out nice, 5,320, and then over 36. And so then in the calculator I went 6,400 plus the 5,320 divided by 36, and got x equals 325.56 to 2 decimal places. And then I did 6,400 minus that, and then divided by 36, and that got me 30. Okay, can a profit of more than $175,400 be made? So when we have quadratics, x squared opens up, negative x squared opens down. So x squared would look kind of like a U like this, negative x squareds look like that. And we'll see more of that in the next section. So this one was originally a negative x squared, so that means this is some sort of parabola opening down. And what we're finding here is the zeros for some given point, whatever this profit was. But there's going to be all this stuff up above it. Like I said, in the next section we learn a little bit more about graphs, and this will make a little more sense. But if we do think of the graph, once we know that, you can see fairly easily that, yeah, you're going to have an area in here where you make more profit. For today in this, you could also just pick a number and try plugging it in and see if it comes out to more than this. So if you plug in x equals 100, which would just be kind of a value between these two, I got a profit of 459,600. So that totally came out more, so then you could say yes. Okay, number 17, a tennis ball is thrown into the air from the top of a hotel that's 102 feet above the ground. The height of the ball from the ground is given by this formula. So what that means is when this side is 0, then the height is 0 feet above the ground. So that's what we're going to want to set up, is 0 equals this. T is time, and how long until after the ball is thrown does it hit the ground. So we're looking for what time makes it come out to 0. So that's just the quadratic formula again. So, oops, I guess I should say T equals negative 14 plus or minus, and 14 squared minus 4 times A is 16, and C 102 all over 2 times negative 16. And then again, I kind of put all that into a calculator and then took the square root. The first number I got was 6724 over negative 32. And then doing the root on that, I got negative 14 plus or minus 82 over negative 32. So if I do negative 14 minus 82, divided by negative 32, that is going to come out to x equals 3. And then if I do negative 14 plus 82, so that would give me a positive number divided by this negative number. That comes out to negative 2.125. So this one is a mathematical solution, but it doesn't make sense in terms of the problem because it's how many seconds after, so we can't have negative time. So x equals 3, sorry, that should actually be a t equals 3 would be our answer.